Hey guys, welcome back to another round of chemistry notes. In this video, we're going to talk about how chemical formulas relate to mass. So first, let's talk about chemical formulas. Remember, a chemical formula shows the kinds of elements and numbers of atoms or ions of each element in the smallest representative unit of a substance. It's basically like a recipe. To make this compound, you need this many atoms of this many atoms of that. And we have two different words, and we have two different terms for the smallest representative unit depending on the type of compound we're talking about. We've talked about ionic compounds. For example, things like sodium chloride or potassium bromate, things that are made of a metal and a nonmetal, or a polyatomic ion are ionic compounds. And the name for the smallest representative unit, the name for one potassium and one bromine and three oxygens, or one sodium and one chlorine, that is called a formula unit. If you're talking about a covalent compound, something like water or glucose, something made entirely of nonmetals and no charges, those are called molecules. So if you're talking about two hydrogens and one oxygen, that is one water molecule. If you're talking about 6 carbons and 12 hydrogens and 6 oxygens, that is one glucose molecule. We're going to be talking a lot about the masses of different compounds, different formula units, different molecules. When you do this, there are two different ways to write mass. There is the formula mass, which we learned about earlier this year. That is the mass of a single formula unit or a single molecule. So to find this, you add up all of the atomic masses of all of the atoms in the formula. For example, if we were talking about water, then we would add the atomic mass of one hydrogen plus the atomic mass of a second hydrogen plus the atomic mass of a water atom, and that would give us the formula mass of water. And this would be measured in atomic mass units, AMU. Remember, when we're talking about on the scale of atoms, we use atomic mass units. The formula mass of water is the mass of 3 atoms, and that's it. So that's why we measure it in AMU. The second way of writing mass is a little bit more useful because it's a little bit on a larger scale. Our second way of writing mass is the molar mass. And that's the mass of 1 mole of formula units or molecules. To find the molar mass, you take the sum of all of the molar masses of all the atoms in the formula. So same thing as before, if you were doing this for water, you would add the molar mass of one hydrogen plus the molar mass of another hydrogen plus the molar mass of an oxygen. And you're actually going to end up with the same number, but just different units. Molar mass is measured in grams per mole. So let's see what this looks like. We've got 2 examples here. Our first one is magnesium bromide. It's made of magnesium and it's made of bromine, but we need to figure out how many of each before we can find the mass. So remember that when you are writing your formulas, magnesium is Mg2+, right? It's an alkaline earth metal. It's in your second group, so it forms a +2 charge. And bromine is a halogen. It's in your 7th group. It forms a -1 charge. So when it comes time to write the formula, we will need 1 magnesium and 2 bromines to cancel out the charges, which means our formula will be MgBr2. So as far as finding the mass, we'll need to take the mass of 1 magnesium and 2 bromines. So then you should look on your periodic table, right? You'll go find magnesium on the periodic table, and the molar mass of magnesium is 24.30. So the mass of all the magnesium together in this whole compound is just 24.30. Then we'll do the same for bromine, but here we have 2 bromines, and each bromine has a mass of 79.90. So we'll do 2 times 79.90 to get 159.80. So all of the mass of magnesium is 24.30. The mass of all the bromine is 159.80. So to find the total mass of the compound, we'll add them together. 24.30 plus 159.80. Typing that into your calculator, you will get 184.10. We can actually put that as our molar mass and as our formula mass, because again, these two things, molar mass and formula mass, are going to be the same number, just with different units. So our molar mass will be 184.10 grams per mole. And our formula mass will be 184.10 AMU. And as you may or may not have realized by now, we are about to re-enter mole territory, which means we're going to be using your molar mass as a conversion factor. Remember, conversion factors are just fractions, where the top of the fraction and the bottom of the fraction mean the same thing. So we could write this as 184.10 grams over 1 mole, or we could write this as 1 mole over 184.10 grams. Usually it's the molar mass that we use as a conversion factor, and either of these would work in a mole conversion problem. So let's start getting that back in our brains because it's about to come up. Before we do that, let's do one more example here. This time the formula has been given to us. To name it, Ga is gallium and it's a metal, so we should know this is going to be an ionic compound, which means we won't use any prefixes, just name the first thing, name the second thing. So this is gallium. It's not a transition metal, it's really just gallium. And then this MnO4 is an ion that you haven't learned yet, but you will learn soon. This is permanganate. So the name of this compound is gallium permanganate. And the formula tells us exactly what it's made of. It tells us that there is exactly 1 atom of gallium. There are 3 manganeses because this 3 sort of distributes in here. So that 3 tells us we have 3 manganese. And then it distributes to this oxygen. But we already know that we have 4 oxygens in every 1 permanganate, and we have 3 permanganates. So that means that we have a total of 12 oxygens because 4 times 3 is 12. So then we'll go look at our periodic table and find our different masses. Every gallium has a mass of 69.72, which means the total mass of all the gallium in our compound is 69.72. The mass of a single manganese is 54.94. So that means that the total mass of all of the manganese in our compound is 3 times 54.94. Plugging that into your calculator, you should get 164.82. And then last but not least, we have 12 oxygens Each oxygen has a mass of 16, so in total we have 192 as our mass of oxygen. So then to find the molar mass or the formula mass, we will just add these three numbers together. 69.72 plus 164.82 plus 192, running out of room a little bit there, will give us our total mass. And plugging that in, you should get 426.54. And again, that number represents both of our masses. The only difference is the units. Molar mass will always have units of grams per mole, and formula mass will always have units of AMU. So if we were going to write our conversion factors using the molar mass, this would either be 426.54 grams over 1 mole, or it would be 1 mole over 426.54 grams. All right, so on the next page, you've got some practice. You've got 6 different compounds. Some of them require you to figure out the name first, so you've got some good naming practice in there as well. Go ahead and complete that table. And when you're ready to check your answers, unpause the video and see how you did. All right, hopefully this is what you got for the names and formulas of your substances, the molar masses, and the formula masses. Again, notice that molar mass and formula mass are always the same number, they just have different units. Molar mass is for a mole of stuff, and formula mass is for one formula unit or molecule. All right, so if you're feeling good about this, it is time to move on to the next video or move on to the quest or the test review, whatever you are working on. So as always, good luck and happy studying.